You can put the microphone down. I'm loud enough talking without it.
All right.
I've got a handout. I'm the Eastern Native Tree Society, or the Native Tree Society is now. I should have enough for everyone here if the couples only take one. Just a little blurb about our organization. I'd have printed more last night, but my printer wanted to eat my paper. Afterwards, I took it apart and found one of those little twist ties stuck up in my printer thing, so it was trying to eat my paper all night, so I didn't print more. I'm talking to you today about old-growth forest. As our district forester said, there's not a whole lot of it around here. Probably the entire eastern United States, less than 0.5% of the forest that's still around are old growth. I have some statistics here and some numbers that we're reading from a clipboard. I usually do PowerPoint presentations, have all these nice graphs on the screen, so I would not be talking and explaining these things to you verbally. How much old growth forest remains? In Pennsylvania in the 1600s, the vista from almost any point would have been an endless sea of trees. However, during the late 1800s, early 1900s, the virgin forests here in Pennsylvania and across basically the entire northeastern United States were all but eliminated. You'd have pictures of this time, just the entire hilltops here would all be completely barren of trees, stumps, nothing at all left behind. They were cut for timber, they were cut for farming, development. Large areas were in the past and still continue to be disturbed by mining operations. From the Shannon State Forest history, there's actually a nice little phrase here. It says, white pine and hemlock stands occupied the shady slopes and moist plateaus in the earliest recorded forests in the region. Many areas were covered by a mixture of beech, yellow poplar, birches, maples, oaks, cherries, hickories, and chestnut. Some of the best white pine in the United States grew here in stands that sometimes approached 100,000 board feet per acre. According to Conrad Weisner in 1737, the wood is so thick here that for a mile at a time we could not find a place the size of a hand where the sunshine would penetrate and reach the forest floor, even on the clearest days. So that's how thick the forests were here. Look out here, there's plenty of sunshine coming down through here. This is because this is all cut down. This is all second growth, primarily deciduous trees. A lot of the early forests had a much higher percentage of white pine and hemlocks in the present day forest because the hemlocks really regenerate in shaded forests more. The white pines an open forest, but if you cut them all down, there's nothing left to put the seeds back. So they pretty much are gone. At the time the settlers first came here, about 90% of this Pennsylvania was forested. Now that's cut down to about 60%. There's 17 million acres of Pennsylvania are currently forested. That's an awful lot of trees. But of how much of that do you think is old growth forest? Today, the Pennsylvania Bureau of Forestry administers 1,580 acres of old growth forest. This is from their website. Now that's a pretty gross underestimate, but that's what they have on their website. There's a lot more old growth forest than that within Pennsylvania State Forest, but this is what's published. And so this is the idea of what people have of how much old growth forest is here. It really depends on what you're calling old growth, how much of it you have. In the United States total, there's 503 million acres of forest. Of that, 24 million acres, about 5% of it has forests that are older than 150 years old. That's the criteria, common kind of criteria for a lot of old growth definitions, 150-year-old trees. 5% of it across the entire country has forests that are older than 150 years. In eastern United States, it's quite a bit different though. How much would you guess that according to the U.S. Forestry Service, of the trees in eastern United States is over 150 years old? Any guesses? How about you? You know all about forests.
It's like 1/10 of 1% or something, I don't know.
It says that forests over 200 years old, there are 49,000 acres. Over 150 years old, there are 2,722,000 acres, or 0.755%. So 0.75% are older than 150 years. And that includes one's 150 years old and older and what's called mixed stands of forest. Within Pennsylvania, there are a number of decent-sized tracts of old-growth forest you can go visit. The largest and nicest, I think, is at Cook's Forest State Park over in Forest County. There you've got about 8,500 acres of forest land along the Clarion River, and of that, by some form or another, about 2,700 acres of that is considered old growth. You've got major stands of white pine and hemlock that are approaching 300 years old. You have the tallest white pine in all of northeastern United States at 184 feet tall, called the Longfellow pine along the Longfellow Trail. You have the tallest hemlock at about 146 feet tall along the Seneca Trail in all of northeastern United States. Pretty soon that's going to be the tallest hemlock in the entire country. A few years ago, a friend of mine in the Native Tree Society was doing research down in the Great Smokies. They were trying to document the big hemlock trees before they died. They surveyed 150 trees, some of them up to 180 feet tall. Every single hemlock over 150 feet that they measured, except for one, has died because of hemlock woolly adelgid. It's not some mortality, it's 100% of all the old hemlocks, and you're still getting a few sprouts coming up that are small. And time for what first appeared in the forest, the hemlocks died about 5 years. Now, we were talking about hemlock woolly adelgid earlier. I just want to sort of interject off topic here. It first appeared in the Bronx Arboretum in 1910. And the first thing that was wiped out was a place called Hemlock Hill in New York City. And then it sort of didn't do much of anything until it reappeared in Virginia, as he said. But there was an earlier infestation, which probably just sort of lay dormant there for a long while without really spreading. You look at the mortality rates for it. Hemlock woolly adelgid is a little tiny bug. There's all kinds of native adelgids. And this is just one that came over here from Japan. And the problem with it is it's reproducing asexually, which means they don't need a male and female in order for it to have babies. They're all female. They're all reproducing. If you have a species that needs both male and female, once you reach a lower threshold of numbers, it's hard for them to mate, and so the populations either die off completely or else they go down enormously. With the asexual reproduction, you just get a few of them survive. You're going to have big numbers in the next year or so because they're just going to spit out babies like it's going crazy. It hasn't reached this far, but I'm sure it will. There's hope by some people that the colder temperatures will slow it down. Well, the colder temperatures does slow down how fast it kills the trees because they only have one generation of adelgid per year as opposed to multiple generations per year. What happens is the little buggers stick their sucker mouthpieces in the base of the hemlock needles, suck out the sap that irritates the needles so they fall off, and the tree is defoliated. And then they resprout again. And they can do that fine, they'll survive that, but if they do that year after year after year, they're going to lose all energy reserves and they will die. Cold temperatures, not really. If you look at the temperature range, you'll get some survival of the adelgid to temperatures as low as minus 40 degrees. And so basically, the range of the adelgid, would extend into Canada farther than the range of the hemlock would. So the entire range of the population of eastern hemlock is under threat from the adelgid. So I'm disagreeing with our esteemed forester here, but what can you do about it not really much of anything. You can treat individual trees, which I'd like to encourage them to do, especially some of the magnificent trees around here, with imidacloprid in areas that are forested, and safari and ones that are not, with stem injections or ground drenching right at the base of the trees. That'll protect them for a number of years, but you have to keep applying it year after year. Aerial spraying, there's nothing really effective. They've got an experimental treatment with a type of fungus that's dispersed in a milkweed that they can spray. And tests in New England, that's been very successful, but no one seems to be interested in applying it. I know Pennsylvania spent hundreds of thousands of dollars in predatory beetles, which hasn't been very effective at all. You know, all the places they did predatory beetles down in the southern United States, North Carolina and stuff, they released massive $100,000, $200,000, 200,000 specimens of these predatory beetles at $5 a piece. And all the trees are dead because the adelgids reproduce faster than the beetles are. And there's some kind of shaky analysis you see in some of these reports. Oh yes, it was a magic success because after a year we managed to find 2 beetles that survived the winter. Well, you found 2 beetles that survived the winter out of 100,000, and you've got 800 million adelgids that survived the winter. So if those 200,000 beetles you released the last year didn't help, how do you think the fact that 5 of them or 2 of them survived the winter is going to assure the long-term survival of the species? It's all kind of silly to me. But anyway, back to old-growth forests. There are a number of old-growth sites here in Pennsylvania. Tionesta Scenic Research and Natural Area over in Forest County and Warren County. There's about 3,600 acres of old-growth forest. If you look at it, I really think it's been selectively logged in the past because there are species that are absent, like white pine is really non-existent in this entire area, and it should be a prominent part of it, given that particular situation, soil, location, and so forth. So I think it's probably went in there, and at least the white pine was taken out of it sometime in the 1900s. You've got Heart's Content, which is a small area. It's got 20 acres of old-growth forest and about a 150-acre park. The 20 acres were areas surrounding a hunting camp that some rich people had, and they donated it. They didn't want their hunting camp area logged, so it was preserved, and it became part of the park system. There's Woodburn Forest in Susquehanna County, about 200 acres. Ricketts Glen State Park, maybe 1,000, 1,500 acres of old growth there. There's little pockets of these old growth all over the place. These are the biggest. Most of the pockets you see that are just a few acres. Along the Allegheny Front Trail, along 6 Mile Run, just before we go into Black-Oceana State Park, there's actually a little patch of old growth there. It's about an acre in size. It has less than a dozen really old hemlock trees. And why these little tiny patches like this survived is because they were on boundaries between 2 different timber leases. And at the time, if you cut someone else's timber, you had to pay them 3 times the value of the timber that you pirated. So if there's areas of disputes on boundaries, those areas just weren't logged. And most of these are pretty tiny, from 5 acres, 10 acres, up to 50 acres. What about maybe 25 acres is, well, is probably big enough to pretty much can be self-sustained if it's surrounding other forests. I'm getting sidetracked, I apologize. When you hear the term old growth, what do you think of? Has to be some way to define what old growth is. Well, old growth isn't an ecological term. It's a term that people have made up for our own usages. And so what you see is each different group of people make up their own definition of old growth to whatever best suits their purposes. So if you're a conservation group and you want to preserve forests, you have a very liberal interpretation of what old growth is. So any of this place with any old trees at all is old growth and shouldn't be cut. If you're a timber company, you want a definition that's really restrictive so you can go in there and say, well, none of this is old growth except maybe those 1 acre or there out of this 100 acres, and the rest of it's just mature forest and we should go in there and log it. So the how you define things really is based on what you want to do. So if you want to argue about preserving a particular forest someplace or a particular patch of woods, you have to be the one that defines what the old growth is. Because if you let the other side define what old growth is, they're going to define it to that patch you want to save really isn't old growth by their definition. A member of our group about 10 years ago went through the internet and he found among government agencies here in the United States, there are 98 different definitions he could find on the internet for what old growth means. And so each one of them was designed for their own particular purpose and what those people in that particular place were trying to do. To some degree, I think that's a good thing, you know, because to fairly evaluate what old growth forest is, you have to define it in terms of the other forests around here. If you're out west and you've got a 100,000 acre patch of old forest and some of it's been logged and they're looking for a timber sale, well, maybe some of that that's already been logged previously or partially logged, maybe you could say, well, that isn't old growth compared to the really pristine stuff in the middle that's never been touched. But around here, if you just have a small patch, even if it's been somewhat affected, you would want to call that old growth because in the context of what the surrounding forests are, that is the closest thing to old growth you've got. And it's good to have pockets of old growth within your forest because even if it's in the middle of the city, these pockets of forest, pockets of old forest, are enclaves of increased biodiversity. You'll see a lot more different species in old growth than you do in younger surrounding forest. Well, maybe that's probably not exactly true, but what you'll see species that are only found in old growth forest in the old growth forest. We don't need more younger forests. We've got lots of younger forests. So you see all these reports talking about, oh, we need to cut this to increase diversity because we're going to have more species in this young forest. Well, that's just silly because we've got plenty of young forest. What we need is more diversity in a landscape scale. So what we need is more old growth forests, more mature forests for those species that need mature forests. You can't look at on a particular forest, oh, here's 100 acres, let's cut half of it so we have more species diversity in this 100 acres. No, you shouldn't do that. You should save that 100 acres because they contain species that's only found in old growth forests in that 100 acres, which are absent from the rest of the surrounding landscape. If you try to look at more scientifically, a lot of people equate old growth forest with forest that's never been touched. Well, around here, all these forests around here have been touched to some extent by past logging, by individual people, by select logging, cherry picking the valuable trees out and leaving the ones behind. You can't say they're pristine because you have things like the chestnut blight came to these forests. In some of the acreage up in Allegheny National Forest, old reports report that up to 90% of the basal areas of some areas of that forest was made up of chestnut. And it's died. It's died because of an indirect human action, the introduction of the pathogen that caused the chestnut blight. So if you say, oh, this has never been touched or never been affected by man, well, everything's been touched or affected by man because we're everywhere. The diseases we brought in here in the forest are everywhere. Everything we've done has affected the forest. So if you're looking for a pristine forest, and that's the only thing you're going to call old growth forest, we just aren't going to find any anywhere because people have been everywhere, and the effects of people's activity has been everywhere. People try to put this on a more scientific basis. There's a report by Dr. Lee Frelick and the other guy's name's Reich, who tries to define it. Next overview of complexities issues are presented in a paper titled Perspectives on Development of Definitions and Values Related to Old Growth Forests by Frelick and Reich, 2003. The detailed arguments they present is sort of beyond their scope here, but I'll give you a couple definitions here just to provide a framework for what we're talking about. A primary forest or natural heritage forest is a forest with a continuous heritage of natural disturbances and regeneration. In North America, this usually means that the forest was not cleared for agriculture or heavily logged for timber. Native Americans, European settlers, many parts of North America, Native Americans, Europeans may have had some minor impacts, clearing for firewood or building little cabins somewhere in amongst it. That's not enough to make something not a primary forest just because it had been touched to some degree. In many parts of North America, large-scale logging is a recent phenomenon, and stand age is greater than that dates of the first logging can be used to establish primary status. So if you have forests around here, cutting really became heavy around here in the early 1800s, say 1810. So if you find trees that are over 200 years old, that means that those trees were here before the settlers started cutting them, and that should be a criteria for what's a primary forest, one that existed prior to human activities. The term old growth itself, as opposed to primary forest, like I said, is one that people made up. And people make it up for their own reasons, for whatever both benefits their own cause that they're looking for. One that I've been using when on our website and been pushing for our group to use, and since I'm one of the most talkative ones on their group, they eventually, if I browbeat them enough, they sort of, most of the people end up agreeing with me. A primary characteristic of an old growth forest is it contains a substantial percentage of old trees, which are generally late successional species for that particular region or environmental regime. These forests should also exhibit characteristics of only a limited human impact, but the level of impact must be considered with respect to other forests in the region. Canopy openings formed by natural processes often found in the larger old growth forest. You think of this forest before people were here, it wasn't one entire mass of mature trees everywhere, but you had areas of mature trees, but you had other phenomena going on in there as well. You have tornadoes blowing down swatches of trees. You have forest fires that occurred naturally. You have a whole variety of hurricanes in other areas. You have other natural processes that are taking down trees, so it's not one homogeneous mass of old forest here and there. What you have is patches of old forest with bits of younger forest in it. It's a mixed age stand rather than one uniform old growth forest across the entire area. And so if you're thinking of old growth forest, you have to start thinking of not just old trees, but there's within what you would consider an old growth area, there's going to be a mixture of old trees along with younger patches that are formed by natural phenomena. It's kind of a term that's well embedded in our society. What is old growth forest? You know, everyone thinks old growth forest and has this picture of what it looks like. And so a lot of the ecologists want to do away with the term completely because it doesn't actually represent a particular ecological feature of the forest. It's just something that people have made up for their own convenience. But I think it's a good descriptive term. It's got a lot of baggage with it and a lot of history with it. And it's a term that we have to keep going because people understand when you say old growth forest, they know what you're talking about. But if you talk about primary forest and all these other things, they're terms they're not familiar with. So they'll just sort of, eyes will just sort of glaze over and not hear anything you say once you start talking about some of the more technical terms. So you say old growth forest when that's really what you mean. I mentioned there's about an acre with maybe a half dozen or so old hemlock trees along the Allegheny Front Trail over near Blackman State Park. Is there some minimum size where something is considered old growth forest? That's something you have to decide. What happens when you get these smaller sizes of forest is you get effects called edge effects along the edges of it. You have younger trees around it, you get more light shining into the forest, whereas there's a big patch of old growth forest, It might be, just like in that phrase you read earlier, it might be dark all the way through it. But if it's a small forest, 5 acres, whatever, all around that edge, you're going to get light shining into it from the younger or missing forest on the inside, from the agricultural fields around it. You're going to get insects coming in from the field and younger forests that aren't normally found in the old growth forest, and they'll penetrate some distance into it. So there is a minimum size below which you're going to get edge effects extended across the entire old growth forest. But even in these cases, you'll find species of invertebrates, salamanders, mammals, and so forth existing within those small pockets that aren't found in the surrounding forest. So you have to consider at what small size you're going to consider old growth forest, and how much level of disturbance from these edge effects would relegate something not to be old growth. So if you want to, are favoring preserving a particular section of woods, of course it's old growth because it's got old trees there. And if you're in favor of cutting it down to, say, build a new indoor football facility, say, no, it's not old growth because edge effects extends all the way through it. That's the current fight they're having down in Virginia Tech right now. They've got a 20-acre piece of land at Virginia Tech that has oak trees 300 years old on it, right on their campus. It's being used as an outdoor classroom for the ecology classes, as a recreational area for people to just go and hang out in the forest. It's called Stadium Woods. The most recent post, I saw that they renamed it Miracle Woods, probably to try to get better publicity for preserving it. What's going on there is the football team wants to build an indoor football practice facility, which will cut down about 10 acres of that, so that the football players can get their exercise at the facility by just going next door to where the stadium is. You know, it'd be too much work for them to get their exercise, say, another 100 feet, couple hundred feet down the road from the old growth forest. You know, they get all their exercise in the indoor stadium, but if they had to go 200 feet farther, that'd be just too much for them to handle. So they have to cut down this patch of old growth forest to preserve it. So instead of having an ecological definition of what an old growth forest is, you start looking at structural features of what consists of an old growth forest. Some of the most prominent are uneven or multi-age structure, including several identified age groups. So you have the old trees, but within an old growth forest, you're going to have younger patches from blowdowns and tornadoes, fires, and so forth. It's not going to be uniform, but it will contain old trees and younger patches. The average age of dominant species approaching half the maximum longevity for species, approximately 150 years for most shade-tolerant trees. This is taken from the University of Minnesota's website, the Center for Hardwood Ecology, and it's one used by up in Ontario for their definition of old growth for the Ontario equivalent of Bureau of Forestry. Now this is kind of silly, half the maximum age cohort. One of my friends is a dendrochronologist. He's going out there looking for really old trees. And so if you say half the maximum age of a tree species, well, if the oldest oak you found is 400 years old, then anything over 200 years old with oaks would be an old growth forest. So say he goes out there and finds an oak tree that's 600 years old. If you use the half the age criteria, well then anything under 300 years is no longer old growth because that's half the maximum age for the species. And so it's a really bad idea, in my opinion, to use an arbitrary age criteria like that for it, because I tease him every time he goes out and finds a new tree. Well, you've just destroyed another 1,000 acres of old growth forest because now it no longer meets the half the maximum age criteria. Some trees are closer to maximum longevity. Again, the longevity depends on the particular site that you're at. Somewhere along here, the maximum age you're going to get for an oak tree might be half of what it would be at some other location. the longevity of a tree in one of these systems depends on the frequency of disturbance. How often do forest fires come through? How often are the trees blown down by tornadoes? And so the average age of the stand, or maximum age of the reach, is a function of how often the disturbances happen. So an area that isn't disturbed as much will have a potential higher maximum age for the trees than an area that's disturbed more frequently. The soil conditions matter too. You find that trees that are growing rapidly in good soils and nice sun and lots of water, they grow real big really fast and then they die. But you see trees that are struggling in little niches and cracks and rock cliff walls, they can reach enormous ages. There's red cedar things growing that are 20 feet high up by Niagara Falls in the gorge that are 1,600 years old that are about this big around, you know? So using a maximum age criteria, or approaching maximum age, you have to consider in the context of where you're looking at, not the maximum age that tree reaches anywhere. The oldest tree found in the world are the bristlecone pines found in the White Mountains of California and Nevada. They've got one that's about 4,800 years old. In the eastern United States, the oldest trees are that they've documented an accurate age for are some bald cypress in the Four-Hole Swamp of North Carolina at about 1,600 years old. You've got red cedars, white cedars up at Niagara Gorge, which are similar in age, very small. When you start getting into deciduous trees, trees that lose their leaves every year, what do you think is the oldest deciduous tree that we know of in the United States? Anybody got any ideas? What's the oldest deciduous tree in the eastern United States? How old do you think they get to be?
We had an elm that lived at 200 at Jersey Shore, the tie-dot elm. So 200-300.
They have found black gum trees that are 650 years old up in Maine. Other trees, we don't really know how old a lot of these trees can grow to be. What happens is the dendrochronologists have a very limited amount of money they have, a limited amount of resources, so they go out and core all these trees where they already know get to grow really old, and then they basically ignore everything else. So we don't know for 90% of the species how old they can grow to be. There's a Hemlock Core counted up here in Tynesta Natural Scientific Research Area, 600 and some years old with a hollow center. People try to extrapolate ages into the hollow center, but that's just bad news because the results that come out are just basically crap. You know, you can't extrapolate them. But so you've got hemlocks right here in the state over 600 years old, just 50 miles from here. Cucumber trees. You know what a cucumber tree is? The oldest they'd ever found was one 350 years old in Virginia. In 2002, one blew over at Elliot State Park. Nothing spectacular about it. It's good size, you know, maybe about this big around, you know. No really noticeable characteristics of it, but they sliced it in two because it fell across a trail. We got a cookie cut out of it, and there's 436 rings on that tree up at Elliot State Park. No one had any idea how old they could grow to be. You've got sugar maples, 460, 480 years old. You've got black gums, 600 years old. You've got cucumber trees. This one's 436 years old. You look in all these forestry books and say, oh, this tree grows to be maybe 150, 200 years old, and they die. And some of this is kind of arbitrary because there's not a really set age where all these trees are going to die. People, you can say, oh, the average lifespan of a Persian take all the ages of all the people who died and all the people who are living, you get a nice average. That's because it's one person lives and then they die eventually, so you get a number. But trees are different. When the tree's seeds come out, you'll have thousands upon thousands of little seedlings sprinkling out from the seeds. And every single year after that, some of them die. And so instead of getting a nice bell curve like you do for human populations, you get a graph that starts up here, here's hundreds of them. A year later, there's less. Then this tail runs all the way out here for what the oldest ones are. And so you can't really tell what the average half-life of a tree is unless you go out and do tens of thousands of trees and do the ages for an entire stand.
Hey, I don't know if anybody else saw it, but there was an article last night on, I think it was MSN or some kind of news source. And there was an 800-year, and I believe it's pine, that's in some park that's now, it's not staffed as much,
It was a red cedar tree in a provincial park in British Columbia on Vancouver Island.
Yeah.
It was
old tree.
like 8 foot in diameter. They went in there multiple times and chopped it up and slowly hauled it away at a provincial park, 800 years old. Okay, presence of standing dead trees and dying trees in various states of decay. You look out here in natural forests, old growth forests don't look like parks. It's not all nice and neat with nice grass everywhere in between the trees and all the broken limbs. It was a forest that's undergoing natural processes. You're going to get a lot of dead trees falling on the ground. You're going to find standing dead trees. If you don't see standing dead trees, it's probably because the area's been logged and all the trees were taken out sometime and all you've got left are these younger trees. You see a lot of standing dead trees in old growth forests. You see a lot of coarse woody debris, branches, logs laying on the ground. These are structural features you can look at to try to identify a forest. In some forests, what you'll see is what they call pit and mound topography. When the tree blows over, it digs up this root mass at the base of the tree, and then the tree rots away, and you've got a hole where the tree was, and this pile of dirt that were in the roots. So you get this irregular type of topography. That's one of the characteristics you can use to help identify old trees. It isn't present in all types of forests, but if it is present, it's probably an indication that this forest is undergoing natural processes of trees being blown over and decay for a long period of time rather than just being timbered and regrowing. What are the value of old forests? Old growth forests are primary habitat for more than 200 species of vertebrates, 3,000 species of invertebrates, and 1,200 species of plants, mosses, and lichens. Snags provide nesting, foraging, and denning sites for more than 40 species of forest birds and animals. Fallen tree trunks and large branches provide shelter and foraging grounds for salamanders, small mammals, arthropods, beetles, etc. Old pine trees provide nesting sites for bald eagles, ospreys, escape sites for things like bears, young bears climbing up the tree. More kinds of lichens and fungi species live in old growth forests than the younger ones. A large amount of nitrogen-fixing lichens grow in old growth forests than the younger ones. Many beetles are obligate. They only live in old growth forests, so you wipe out the old growth forest and the beetle species are gone. Woodpeckers and 39 species of songbirds are more frequent in older forests than youngers. Several kinds of hawks and owls basically only found when you have a large contiguous area with at least a core of old growth forest. They can also be thought of as samples of like a genetic reservoir. The old trees in an old growth forest, they have good genetics, or else they would have died a long time ago. So if you get seeds from a big old tree, you know that big old tree has good genetics. It could be a combination of being in a good position or a good soil, good light, good water, but if it's an old tree, it's been there for 300 years, it survived all these storms, it survived all these other activities, that means it's got a good set of genetics. And you cut down the forest, And what you're going to get the trees that grow them fastest will be the ones that will repopulate the area primarily. And the trees that grow the fastest aren't always the best for the long-term future of the forest, of that particular species. They're just the ones that grow the fastest, the ones that are going to repopulate. You'll get some genetic drift, but generally, if you cut down everything here and it grows back with the same species, you're not going to get a whole lot of genetic drift. But if you're sampling for what makes the best seed for best forest for the longest lived trees, that you need to have these genetic reservoirs of old trees. When you're looking at a tree, how do you decide what an old tree is? Obviously, you can't go out there and core every single tree that you run across because there's just too many of them. So you have to have some arbitrary technique to look at the trees so you can pick out which ones are the oldest, which ones would be worth your sampling, which ones are not. Sometimes you can tell by looking at a tree that's old. Sometimes an old tree will just look like any other tree and you can't really tell much difference. It's not always the biggest tree in the forest that's the oldest. A lot of times the biggest trees are ones that are growing in a particular area that happens to be particularly good soil, particular good combination of light and water and soil. They're just big because they grow the fastest. In a forest like this, if you want an old growth forest, almost every time the oldest tree is not one of the ones that's the biggest or most spectacular looking. It's one of the ones that's sort of like medium-sized trees. So size alone for most deciduous trees is not a good criteria for what's the oldest. In conifers, pines, hemlocks, bigger is usually better for those. But for deciduous, it's not really good criteria. If you look at these trees, see how nice and straight these are because they're growing in the open. You see a tree that's old, what you'll see is a tree will come up here and sort of twist and spiral up, they'll sort of snake up to the canopy. A tree that's snaking up towards the top, that's a tree that's old. You look at the top of the trees, you see lots of broken branches up on the top where things have broken off and little shoots going straight up. There's called reiterations. The broken tops are a good indication of old trees. Big, thick branches near the top that are broken. Lots of reiterations where the trees have broken off and started again. Because if you have your head stuck up in the weather for 300 years, it's going to get broken off. If you're looking at a tree up there with a nice pristine top, you know that tree hasn't been up there that long. It hasn't undergone those 300 years of weather and ice storms. A tree up there with a pretty top is one that's just not that old. Other characteristics which you won't see around here because these are all young is you see these nice characteristics of bark on the tree. Older trees, they'll have a feature called balding. You look on the side of the tree and you'll have real thick heavy bark here, and the back side of the tree or one side of the tree, it'll be virtually smooth. Balding is a process that takes place in older trees. It has to do, they think, with a period of more rapid growth on these older trees, basically just flakes off the bark in these particular areas. Exactly how it forms, we're not really sure, but balding is a consistent feature of finding old trees. So you go out there and you look at these trees in the forest, you see one that's all twisted up like this, you see ones with a broken top, you see some with smooth bark, that's an old tree. Those are the ones, if you're going to be coring a tree and you have a permit to do so, those are the trees you should be picking out to core. As I said before, there's not really any pristine forests. All the forests around here have been affected by human activity, either directly through timbering, agriculture, mining activities, just urban development. The ones that are not affected directly are being affected by the various diseases we bring in here, the chestnut blight, the hemlock woolly adelgid, emerald ash borer, all the blight on the butternut trees. All of these are things that are being enhanced by human activities. So you're not going to find a perfect forest anywhere. So you have to try to find what's the best of what you have left. Why do these old forests survive? Well, there's really only a handful of reasons why. They weren't cut because they're part of a private estate, and the people who owned it wanted the forest for their own pleasure, own usage. That's why Heart's Content survived. That's why the old-growth forest up at Cook's Forest survived. The Cook family is a big timber family, and they made millions of dollars harvesting every place around there, but right around their own home, they didn't cut the trees. There were old-growth trees overhanging their main lumber mill on Tom's Run in that area. They just didn't want to cut around their own homestead. And towards the end of the time, there was actually a fight within the family about whether they should just log off that last little bit or whether it should be preserved. And one of the guys' name was Anthony Cook, the grandfather of President Anthony Cook, was fighting to have it preserved. And they had public fundraisers for the public to raise money to purchase the timber rights to that last little bit of land to preserve Cook Forest State Park. Other reasons are the forests are growing in the area, they're just crooked and mangled, and the trees really aren't worth much. It's not profitable. An example might be some of the trees, say at Mount Logan Natural Area up near Williamsport. There's a massive talus slope. There's a vertical bed of quartzite sticking up there. It forms a ridgetop. Along the sides of their talus slopes are big chunks of boulders this big around or smaller sliding down the hillside. Trees are growing in that talus pile. Some of those trees could be 200 or 300 years old, but they were never cut because they're so twisted and mangled by trying to grow up through those rocks and through the movement of the rocks that they're perched in, that they're just too crooked to be worth cutting down, so they've managed to survive. You see, there's probably a lot more old-growth forest areas of these talus slopes, you see them all across eastern Pennsylvania in particular, that were probably never cut because the trees were just weren't marketable. Around the end of the timber boom, say around 1920, there are some areas that still hadn't been cut. And what cutting they were doing, they're just going in and selecting out trees that were most profitable and leaving the rest behind. So some areas that has old growth or old growth characteristics are trees that just wasn't worth very much, so that it wasn't worth their time to log them towards the end of the lumber boom era. The other areas are ones where the walls, like a steep valley walls, where it's too difficult for them to mine it. You know, they could cut the steep valley walls in a narrow stream. Yeah, they could cut the trees down, but how are they going to drag them out of there? If it was really valuable, they could probably do it, but if it's sort of questionable about whether they're going to make a lot of profit or not, these areas, because they're just too difficult to log, were just left behind. You see, there's a number of gorges up along Lake Erie, for example, a 6-mile run up there, 6 Mile Creek up there, very, very narrow. The stream bottom is probably about as wide as this, and slopes sticking up 150 feet. Along the sides of those slopes and the top of those ridges are old-growth forests. The ones on the slopes were just too difficult to cut, and the ones at the very top, that's an area because the proximity to the valley was extremely dry. So you've got old trees up there, 200-300 years old, hemlocks and birches and other things, but because it's such a dry area, the trees are all stunted. They don't look impressive. They really are old growth, but not impressive. A broader area in the United States is one called the Cross Timbers area, which extends across much of eastern Texas and Oklahoma into Arkansas. These are post oaks. They're kind of more a prairie type area, but you've got trees about this big around, all gnarled and bent and stuff. Some of these are 300 and 400 years old, some 500 years old. They were never cut because they were not valuable enough commercially as timber, so they persisted because they just weren't worthwhile cutting down. So there's old growth remaining. There's old growth in the forest system, in these talus slopes, that are not recognized as such because, not to be disparaging of foresters, because we've got a wonderful one here, I think. If the timber isn't worthwhile, isn't commercially viable, forestry people in general, maybe not the park managers because they're doing something different, but foresters, people in the commercial logging business, just ignore them and pretend they don't exist. If they can't make money with them, they ignore them. I think there's probably a lot of old-growth forests that are still persisting, these narrow valleys, little patches here and there, 10, 20 acre range. Old-growth forests and these tailless bands around a lot of these mountains, more in the eastern United States, are still surviving. Part of what our group does, the Native Tree Society, I pass that leaflet around, is we try to locate these patches of unusual or unique forests and document them, where they're located, characterize them, get accurate measurements of how high the trees are, what species are present. That's part of our mission. There are other types of unusual forests to consider. He mentioned the forest at Marion Brook's natural area. I know I'm running late. Marion Brook's was an area that was completely logged over. There's piles and piles of brush there. Scraps left over from the operation. And the area burned. The area burned really, really hot. It burned so hot that basically everything in the soil that was organic was burned out of it, and all you was left behind was this mineral soil. And in this pure mineral soil, there's only a few species that manage to grow up in it. And one of them is the paper birch, like you talked about. So you got development of this almost pure stand of paper birch in this mineral soil that basically nothing else would grow in because it had been burnt so badly. And then after it grew up for a while, there's probably a second fire because you can see all the trees are splayed out like this, which means the original tree grew up to some height, then burned off again, and then it grew up again from the root mass. So there's this whole series of fires in there, and it's an amazing place. But what you see, if you look at it now, what's the long-term future of this place? It's probably going to be gone because now the entire forest floor is covered by either blueberries, huckleberries, or bracken ferns. You have these paper birches all over the place, big, impressive-looking trees, but there's no regeneration of them because there's no regeneration on the forest floor underneath these brackens and blueberry bushes. So when the existing paper birch trees die, they're going to be replaced by maples and oaks and stuff that are encroaching in from the sides. And this is a unique area that's really neat to look at. And long-term prognosis for it just isn't very good. Long-term prognosis for a lot of these small patches aren't very good because, say that small patch over on the Allegheny Front Trail that's just maybe a couple acres and maybe a 10 old hemlock trees on it. What happens when those 10 hemlock trees die? Well, what happens is, technically this would still be a primary forest, one that hasn't been cut. The only problem is it would not be distinguishable from all the younger forests around it because the only thing that distinguishes it in this small size with all the edge effects from the younger forest is the presence of the old trees. When those old trees are gone, you won't be able to even tell that it was there. So it's probably not going to survive. Places like Stadium Woods, it's not going to survive. Like, what's going to win out? Some trees or the Virginia Tech football program? I'll give you a good guess of which one's going to win out in that argument. Should we make an effort to preserve them? Yes, because even if they're mutilated and not very large, they can serve, if surrounded by other forests, as a seed to basically expand old growth characteristics and some of the remnant populations in the old growth pockets out into the surrounding forest. Even if they're a small park in the city, the presence of a forest provides a nice outdoor place for people to visit and people to get in touch with nature to some degree. I'd really like to see them kept in a more natural area, but you start getting to urban settings, questions about liability from fallen limbs, fallen trees, and so forth. And so people clean up all the branches, clean up all the debris so no one ever falls down and gets hurt. If they could be allowed to revert to their natural state, that would be great. These small pockets, the big problem is that when you lose a species in one of these small pockets of forest, there's no way to replace it. Say we're an area here, 50 acres with 5 or 6 white oak trees. If the white oak dies, and this is surrounded by fields, there's a good, what's going to come in and replace the white oak? You're going to slowly, over time, you're going to lose species. Isolated islands like this of diversity lose species over time, so if you're going to maintain them, you have to artificially reintroduce species that are lost and try to make it look more like it did originally, or else you're going to just get an increasingly simplified ecosystem. I'm all in favor of the Wilderness Act and so forth, but if you look at some of the examples of them, say Thompson Island, one of the 7 islands in the Allegheny River Island Wilderness up in the Allegheny River. Thompson Island, about half of it's covered during the summers by invasive Japanese knotweed. Underneath the knotweed, there isn't any regeneration of natural trees. And the knotweed's taking over more and more of the island every year. There's nothing else that grows except for a monoculture of knotweed. Once the existing trees that stick out above it die, the only thing that'll be left on Thompson Island will be a single monoculture of knotweed. And so, because it's wilderness, people can't go in there and do anything mechanical to try to remediate or get rid of the knotweed. It just has to be left to basically die. And a nice 90-acre island of nothing but Japanese knotweed isn't really what I consider an ideal wilderness area. So I like the wilderness designations, but there's 2 ways of looking at it. The absolute strict no mechanical things going on, that prevents abuses in it, but also prevents actions which would help push it in the right direction. A lot of these ecosystems, you find it's the natural system, it can either continue on a course where most of the natural trees will remain, and it'll look pretty much like, it'll sort of evolve towards what the forest looked like originally, minus all the trees that have been died out from various diseases and insects, or else it'll be one taken over by invasive exotic species. And there's sort of, a lot of them are sort of a tipping point. If you're just able to push them in the right direction that you want, that would be great. But if you weaken the wilderness protections, it'll just end up, they'll be being cut down. So I gave you out these papers. If any of you find old trees, old forests, big trees, you can contact me. My email's on the back, the website for our groups on the front. We have a web page, we have BBS where people talk, back and forth discussions, and we even have a Facebook page. Questions, comments?
Just one quick question. You read about these 280-foot high white pines and hemlocks. Were they pretty much an anomaly before the forest started getting cut? And what was kind of the average height? Or, I mean, you explained different type sizes, but what were you looking at there?
I think the 280-foot white pines are just an exaggeration by people trying to outdo each other. The tallest one we've ever recorded was one that was 207 feet tall, and that was by cross-triangulation down in the Smokies, where the trees grow the biggest. Finding one over 180 feet tall is unusual, very, very rare. We have large enough chunks of old-growth forest remaining containing white pine that we've got a fair representation about how tall the species can grow. And they just didn't grow that tall. They're tall tales made up by lumbermen to tell their friends.
180 is pretty good.
I could see maybe up to 220, 230. Anything over that, I think, is just pure imagination. The tallest one, like I said, was 207. The top broke off. It's now regrown to about 188. The tallest at Cook's Forest, you got one 184. That's the only tree over 180 feet north of the Great Smoky Mountains. The tallest one in eastern United States isn't a white pine. The tallest tree currently in the eastern United States is a tulip poplar, Liriodendron tulipifera, is 192 feet tall in the Great Smoky Mountains National Park. That's the tallest in the eastern United States.
Might I say, you know that our timber industry here started with the spars that came out of this area. And some of those trees were 140 feet, 160, they could use them for spars. In the initial coming up the West Branch, they found the best spars and shipped them down the Susquehanna. So we had some of the most beautiful trees at that time. It was well known. And that's a lot of the millionaires on Millionaire World Road in Williamsport that come from that. But we had some huge pine trees here. And we got actually written research on how some of those things was measured and so on. So we did have some huge, huge pines at one time.